Hi, my name is Gary Schnell, and I'd like to welcome you into my home near Milwaukee, Wisconsin. I've been putting a number of YouTube videos together to highlight different elements of my recently published book. But today, what I would like to do is take a moment to maybe try to put a video together that helps people to understand a little bit better the four principles of quantum mechanics. I am aware, since it took me so long to understand these things after reading multiple books and thinking about things and putting things together, that these ideas they're counterintuitive, and they're almost ineffable because they are counterintuitive. They don't rely on cause and effect like we're used to, like classical physics depends on. Instead, quantum physics is a physics about probabilities. And as you may have gathered from the chapter that I did regarding my book, the things that go into quantum physics, they are just difficult to explain and don't seem to make any sense. So I'd like to take a little bit of time to tell a story. The story is about a fellow who is deserted on a desert island, and he has no way of getting off, so he sticks a note in a bottle of Louis Cherry Bounce, a local Milwaukee brew, microbrew, good stuff. And so he sticks the note, of course he's drunk at first, sticks the note in the bottle, and the bottle is carried off by the water. Now, as the bottle is carried off by the water, it becomes smaller and smaller to the man who sent it, to the point where it's no longer visible. And it has lost its locality to the man who sent it off because it's no longer visible, we can imagine. And it has become non-local, and wherever it ends up, it's out of his sight. Wherever it ends up, that will be non-local to him and become local to the people or the island or wherever it ends up. It will have its locality there, but be non-local to him. So the bottle's floating around and floating around and floating around, and it can go anywhere. It can go past any of these islands. It can go to this island. It can go past those islands. It can go to that little island up there, or that island over there, that one down there. No one knows. That's what's called the principle of uncertainty. And it has to do with the fact that things are non-local, and it's hard to know where they're going to end up with any certainty because they're non-local. So essentially what ends up happening is this bottle floats around, and it ends up on this island. Now this island has a funny name because it's kind of an odd island. It is called the Island of Identical Twins. And there are nothing but identical twins living on this island. And so the bottle has floated here with the message in it, carried by the waves. And the twins find the bottle, they open it up, and they read the message. And what's happened is the information in the bottle has been transformed. It has been transformed as it's been carried by the waves into the experience of the two twins. That is what we call complementarity. So we've got non-locality. It's now local to them, but non-local to him. We have uncertainty, and now we have complementarity. So the twins, they happen to have a boat, each has a boat of his own, or her own. And they sail off in 180-degree opposite directions. And these are two twins that know each other well. They know what the other's thinking. That's how close they are. So the one twin turns left. Well, the other twin knows this because they know each other so well. And this twin turns right. Now, this is what we call entanglement. When these two twins that know each other so well make a move, the other knows it instantaneously without having to be radioed or have a message sent. So eventually the twins find this fellow and save him, and they go off to their island where they order 3 Louis Cherry Bounce and celebrate the man being safe. So we've talked about the principles of non-locality, complementarity, uncertainty, and entanglement. Now let's talk a little bit about how they translate into quantum physics. Let's assume or pretend that this is no longer an island, but maybe a planet. And these things could be planets or stars, or let's pretend that that's a star. And there are photons given off by the star. And they can go in any direction. So there certainly is a uncertainty about where they might go, who might capture them. And as the photons leave, they become non-local until they are seen by perhaps one of the twins. One of the waves of the photon is captured by the retina of one of the twins. And that is an example of complementarity. So we have non-locality, uncertainty. The light wave can go anywhere. And let's examine a little bit about entanglement. Let's assume that there are 2 photons that left together at the same time, and they were very, very close to each other, very, very intimate, and they shot off in 180-degree different directions. As soon as this twin captures this photon, regardless of how he or she might capture it, the elements, like let's assume one of them is spin. Photons have a certain spin, so this photon is captured again by the retina. This photon immediately has a complementary spin to the one that was captured. It's assumed that that's because these 2 photons were so closely entangled. That's why they call it entanglement. And it doesn't happen until the information of the wave, of the photon wave, until it is what we call collapsed. So this wave is collapsed, and it's collapsed into space-time by one of the twins, and immediately the information of the other photon is known. Now, there might be other ways of understanding this. As I suggested in the video that goes with my book, I think it's worth considering, though I think there's some disagreement about this, that the reason this information is known immediately is because it's carried as waves of information, and the waves of information are apart from space-time. You see, the problem is nothing in space-time can go faster than the speed of light. So if the information of the one photon is known there and it's immediately known up there, well, that violates the transmission of information the transmission of anything faster than the speed of light. But now we know that this has been done, and as I say, it had been presumed that it's because these 2 particles are so intimately known to each other. But let's consider that because this information wave is apart from space-time, that it can be immediately known because it's apart from space-time. It's not dependent on transmission of information within our 4-dimensional space-time. It is outside of space-time. So the information is immediately known by the other photon up here. Now, that was my speculation in the book, and I think it's worth considering. So I hope I've helped with this story helped folks to understand a little bit more, a little bit better about the 4 principles of quantum physics. I would certainly appreciate any comments or any questions or any concerns that anyone has. You can just write them after you're done with this, or type them after you're done with this video, and I'll get back to them as soon as I can. In the meantime, thank you very much for your time, and stay healthy and be well in these days. Thank you. Bye.